Hey guys, in this video I'll be going over delete node in a binary search tree. So basically this problem gives you a binary search tree and it wants you to delete a node with a target value. So if the value here is 3, they want you to delete it, and you can either move 2 up into its place or 4 up into its place as long as it maintains the binary search tree. Where all the elements to the left of a node, all the nodes to the left of a node are less than it, and all the nodes to the right of it are greater. And yeah, it wants you to solve it with runtime with respect to height of the tree. And so yeah, I'm pretty sure the problem is fairly simple to understand. So yeah, so let's get into the solution. So essentially, what you want to do is you just want to search through the binary search tree as normal, because let's say you have like some numbers here, like it doesn't actually matter, but let's just say we're looking for like 3. We look at our overall root of the tree and we say, oh, wait, 3 is less than 5, so we know we want to look over here in this direction. And then we go to the left guy and we see if that guy's equal to 3. And so, of course, you won't be going over all the nodes in the tree, just through the height of it. So that's just like standard usage of a binary search tree. The more interesting part is what happens when we actually find the node we want to delete. And so basically what happens when we find 3 over here and we want to delete it. So there's 2 ways to really do it. You could shift the right guy up in there or the left guy up in there. In my solution, I shift the left guy. It's pretty arbitrary though. So basically what you know that all the values in the right guy here, in this right guy, they'll be larger than the largest value in this left guy. So basically, if we start at this left guy here, we can just keep on taking the right, like it doesn't matter what's on the left side, we don't really care about that. We just keep on going right, right, and right, because we'll know that's biggest, and then whenever we reach the end, there's nothing this node's pointing to. Whenever we reach the end of it, we know this is like the largest value in the left subtree here, and then basically we can just grab this right guy. We know it's larger than all of the guys in this left subtree, so we can just tack it on to the end here and point this guy's right to this right guy here, because then we know, hey, look at this node, everything to its right is greater than it, which is true. And then after we go all the way down this right thing and tack this thing onto the end, then what we can do is we can just point this guy, like have this pointer point to this guy instead of this 3. So then that effectively removes 3 from it and still keeps it as a binary search tree. And yeah, so let's just get into how to implement this. Yeah, so by far and away the easiest way to implement this is recursively, using like an x change x type of scenario where yeah, I'll just step through this logic here. So of course if the root is null, you just don't worry about it. So essentially this is the only important part, okay? Well, this is the most important part. So this is the part where you traverse through the tree to find the node that you want to delete. So if our value is greater than the key, we know that we should look at nodes less than it, so we run delete node and just go to the left of it. And whatever this value returns, we'll point that to root.left. So it's like an x change x type of algorithm. And then you go to root.right and then you run delete node and pass in that, and then basically this will basically recursively go through the tree until you find the node that you want to delete, because it'll just walk through this binary search tree until you find the node with the value that you want. And once you see that value, like let's say you pass in delete node root.left and you go to this side here. So 5, you're looking for 3, you go to the left because you want a smaller number. You find 3. So then what you want to do is you enter this case. What you do is, first of all, so this part here is the logic where you go all the way down this like the left guy of it. So if we find 3 here, the left guy is 2, and then we'll want to keep on going right to find the largest number to attach this 4 to the right of that. So if we find 3, here we get the left guy of it, and here we also get the left guy of it. Just so I grab this guy just so I can return it, and so then you keep on going to the right after that, and then so this moves this guy ML, he'll start here and he'll keep on going to the right, and so eventually ML will be this guy, and then we'll make that guy's right equal to this right guy, so we'll point this guy to this this guy's right child will be this guy, so it'll also carry over whatever this guy has in his children, and then we just return this left guy. We'll return this guy, and then we'll make this guy here, instead of pointing to this guy, we'll just be pointing to this guy because we returned him. Because when you do here root.left equals delete node, when this thing runs and it'll return this guy is left pointer, instead of pointing to this guy, it'll point to this guy, and so then that's basically just the answer, and you return the starting root that you were given. Because yeah, and that's about it. So yeah, we'll submit this. Yeah, and this is the fastest possible runtime because you're just going through the height of the tree, so yeah, you don't even need to look at all the nodes in the tree. You just need to go all the way down to the bottom of it. And yeah, so that's about it for the video. Thanks for watching, and I'll be back with another video tomorrow.